So assessment item number 23 with no numbers in it. People hate these questions, but let's just keep it simple. I start with two consecutive integers. What do we call our unknowns in maths? X and Y. I square each of them. You guys know how to do that. I square each of them. Then I add the two squares together. So you're adding maths. You're making maths from the words. And then we're asked to use words, letters, diagrams, and or numbers. So we're covering every eventuality here to prove that the total must be an odd number. So let's have a look here. The only thing we haven't taken in here is that they're consecutive. So we have an x and a y squared here. So if you're thinking to yourself, well, I maybe could do with just having one letter. Well, if they're consecutive, what can we say? If x is the first number, in terms of x, the second number would have to be the one after it, which is x plus 1 squared. So let's just have a look at what this simplifies to be. X squared plus x squared plus x plus 2x, you should know this by now, plus 1. We don't need the bracket, but you should be able to square this guy at this point of third year. If you can't, and you want to take a little bit longer, just x plus 1 by x plus 1, and use whatever method you feel comfortable with to get to this answer here. So we're going to have 2x squared plus 2x plus 1. And we have to show that this is an odd number. So this should be easy enough because look what's going on here. We've 2 times something, we've 2 times something, and then we're adding 1. So you're kind of going, wow, I really don't know, how do we show this is odd? Well, let's have a look at what happens if we multiply a number by 2, any number. So we'll take a couple of numbers here. Let's multiply 2 by 2, and let's multiply 3 by 2, let's multiply 4 by 2, and let's multiply 5 by 2. That should be enough. So 2 2s are 4, 3 2s are 6, 4 2s are 8. Can you see a pattern here? 5 2s are 10. So these are the numbers. These could be my x squareds or my x's. But it looks like if we multiply any number by 2, we get a series of even numbers. So these look to me, and hopefully to you, that this is definitely even. This is definitely even. And we're adding 1 to 2 even numbers added together. So that's what they're trying to get here. So what happens if we add 2 even numbers together? Well, let's see. 2, 4, 6, 8. 2 and 4 is 6. 4 and 6 is 10. 6 and 8 is 14. When we add 2 even numbers, we get an even number. So now I have an even number plus 1. And if I have any even number plus 1, if I take 2, 4, 6, 8 again, if I add 1, I'm going to get 3, 5. You could put a plus 1 here, you put an even here, maybe make a proper table out of it. 3, 5, 7, 9. So therefore, even plus 1 equals odd. You could use the word evens, and you could use QED for quod erat demonstrandum, that which must be proven. And if you're good at proving things in maths, you will be a brilliant mathematician. Don't fear these questions. They always work out nice if you take your time and do one simple step at a time. In assessment item 24, we're asked to think about triangles, and you can see here in bold we're asked to prove. So for those really high level mathematicians, you're going to be asked to prove something. So they're testing, can you take your time? Do you know something about the question that's being asked? Think about triangles. Now, if we think about triangles, let me just do this. I'm thinking about a triangle. Here's one side, the base of a triangle. Here's one side here. It's not very long. And here's another side here. It's not very long. If they don't meet past the middle, they're not going to form a triangle. You can see here. So this is the key to this question, is our little bit of knowledge about a triangle. Is if the sides of a triangle are A, B, and C. I might just complete this triangle here. A, B, and C means A plus B has to be greater than C, or it won't form a triangle. So let's think about triangles that have a perimeter of 15, 2 or more equal sides. So that could be 2 or 3. So 5, 5, 5 definitely works. and then each side a whole number of centimeters, so an element of natural numbers. And then we're asked to prove there's only 4 of these triangles and we don't need to construct them. Okay, well, let's just use this knowledge here. A plus B has to be greater than C. There are other things about a triangle that we may need. Let's have a look. 5, 5, 5 does work because A plus B. And now I'm going to give them length A, B, and C here. 5, 5 works because A plus B is greater than C. Or you could write 10 is greater than 5, so we don't have to write it all the time. 10 greater than 5. So let's just change them around. What about 6, 4, 3? So now, if we look at A and B, A plus B is greater than C, but if we do the triangle 13, 1, 1, you can see that A plus B is greater than C, but you know this triangle is not going to work. Why? B plus C is not greater than A. So its 2 sides have to be greater than the other one. So does the second one work? B plus C is 7, A is 6. This one will work for us because B plus C is greater than A. So when you can get used to using this terminology, maths does become a little bit easier. 7 is greater than 6. It's just about not having a fear of kind of things that you haven't done before. Watch them done a few times, practice them yourselves, and you'll get better at maths. So what else? Let's see. Let's keep going here. Can we get a 7? Will a 7 work? What else can we have? We have a 7. The other 2 sides, if they add up to 15, we'll have to add up to 8. So what about 4 and 4? 7, 4, and 4. You can see here B plus C is greater than A. That will work for us. A plus B is greater than C. That they all work here. 8 is greater than 7. So that will work. So let's see, can we see some sort of pattern going on? We have one starting with a 5, one starting with a 6, one starting with a 7. Can we have one starting with an 8? And then, well, you would have time in an exam to check a few that don't work. If it starts with an 8, 15 minus 8, the other 2 have to add up to 7. Now, how would they add up to 7? 6 and 1. It could also be 3 and 4. So let's test these two. 6 and 1 is not greater than 8. So that's not going to work for us. So maybe write that down. B plus C is less than A. So no. And we can see here again, I'm just going to rub this out. B plus C is also less than A in this one. B plus C is less than A. And let's see why it doesn't work. If this one is 8 cm, you can see if the other 2 only add up to 7, if I draw 7 cm beside it, it's going to be shorter, so we can't get to the other side. So we definitely can't have 2 pointy bits or 2 other sides, it would be longer. So we can't have either of these 2. So we have 3 so far. We need to get a 4th one, and that will have proven that there are only 4. So to finish it off, I'm just going to refer back to the question here. A perimeter of 15, and we have our triangle ABC. I'm just going to use some algebra here rather than the trial and error method. So if the 3 sides add up to 15, and we have 2 or more equal sides, we could have 3 equal sides. So I'm going to just tick this one. So if they're all equal, we could say that A plus A plus A, so 3A is 15. So A is equal to 5. So they're all 5. That's my 5, 5, 5. So this is the proof really rather than the trial and error method. Now if there's 2 or more equal sides, we'd have A plus C is equal to 15. We have to have 2 the same. So 2A plus C equals 15. And if the 2 of them are equal and they're all natural numbers, there's not that many options. So we'd have a 1, and a 13, a 2, and an 11, a 3, and a 9. They're all adding up to 15. 4, 4, 8 and 7. You can see the pattern here, 13, 11, 9, 7. 5, 5, 5 is the one that worked for us. These are the only ones. We're going to have 6, 6 and 3, 7, 7 and 1, and then we go to 8, 8, that'll be 16. So these are the only potential natural numbers that work for us. So this is, let's just finish off this proof and see which ones work. We'll put a tick beside them. Based on our equation, 2a plus c is equal to 15. Just create a nice tidy box. So based on our little bit of knowledge here, that the two smallest sides, maybe, if you want to describe it like that, will have to be greater than the biggest side. This can't work. You can see we have 2 1s, but there's no way we could connect them to a 13. Similarly with 2 2s and 2 3s. So this one will work, this one will work, this one will work. And just to finish off the algebraic proof, if a plus b is greater than c, we turn it in terms of a plus a is greater than c, or 2a would have to be greater than c. So maybe over in this one you could say 2a is not greater than c, not greater than c, and you can say here 2a or 2a is less than c, maybe might be a better way of describing it. 2a 6 is less than c, which is 9. So 2a here would be 8, 2a is greater than 7, and so on if you wanted to just add in your algebraic proof. So that's this question complete, one of the trickier ones maybe.